So none of this matters for the 5 in reality, because this is what we have as our input. Did I get that right? Did I change that back right? Yeah, I changed it back right. So we decided that the steady state output for this was going to be 2 times 39 divided by 13. What was that again?
6.
H of 0 times 8. This is my 8. This is H of 0. B. Show all of the poles of the output signal on the axis provided. Make sure I can tell the values of the real and imaginary parts. Poles of the output signal are going to be the poles of what and what?
Input signal and the
Input signal and say that louder, Jake.
input signal and the transfer function.
Input signal and the transfer function. Which poles would you like to find first? The input signal and the transfer function.
Transfer function.
Transfer function. Okay, let's go find the poles of the transfer function. So they come from the bottom. They come from the s squared plus 6s plus 13, and this doesn't matter at all. How would you go about doing that? There are multiple ways to do that.
I'd put in the quadratic factor.
You would do a quadratic equation. You would say s is equal to minus 6 plus or minus square root 6 squared minus 4 times 13 all over 2. This is what you do. Would that work?
Yeah.
Sure. That'll give you the 2 poles. And can you tell me right away what the real part is? Negative 3. And the other part? 6 squared. 6 squared is 36. 36 minus 4 times 13, which is 52.
16.
Pardon?
Negative 16.
Negative 16. So what's the 2 numbers that you get?
4j. Oh, 2j.
Why 2j's to the 4?
Divide by 2.
So divide by 2. So you would get those answers. That's perfectly okay. Perfectly good way to do it. I mean, other ways to do it.
2a plus a squared b squared.
Yeah. You can look in the table and see that there's an entry for s squared minus 2as plus a squared plus b squared. And the table is the minus, right? Yeah. If 6 is equal to minus 2a, what is a? Minus 3. If 13 is equal to 3 squared plus b squared, b is equal to what? 2. Do we get the same a and b? Yeah. And there are other ways? Yeah, but they're harder.
How'd you do that?
Oh, don't do it if you don't like it. Use your quadratic. That'll work just as well.
I don't like it.
All I'm doing is, this is actually completing squares sort of stuff, but the reality is this is one of the forms of the denominator that's like this. This 6 has got to be equal to the minus 2a, therefore a is minus 3. This 13 has to be a squared plus b squared.
Oh, got it. Okay, it's pretty easy.
So which poles are associated with the transfer function?
Minus 3 plus 2j minus 3 minus 2j.
So those 2 poles. Are they the only poles in the output?
No.
Nope, there are also poles associated with
Yeah.
the input. The input. What are the poles associated with the input? Without going to x of s.
Oh, okay. Origin.
The origin.
Negative 5.
Negative 5.
Plus or minus 7j.
Plus or minus 7j.
Oh, that's easier.
Oops. It's easier if you know what you're doing. What's going on here? Where it's going? What's happening?
You didn't
part of the pole comes from the exponential, and the imaginary part of the pole comes from omega.
Yeah. So this is my A, and this is my B.
Oh, yeah.
A, B, plus or minus B.
So you just look at your Laplace transform.
Does this matter? Doesn't matter what the number is. It has nothing to do with this file. What about this? Does this matter as far as the pole locations are concerned? What the value is? As long as there is a value, does that mean there's a pole there? So what are you expecting as an output? Well, I'm expecting ringing of not much ringing at 2 radians per second. That decays with a time constant of 1/3. I'm expecting a bit more ringing at 7 radians per second. That decays at 1/5 of a second. And I'm expecting some DC output that's constant.
So if there were no A, your poles would be on the imaginary axis, correct?
Yeah, if this piece were not here, if that green piece were gone, then I'd have the 2 poles right here.
Let's see.
And that would be a steady state output. C, what is the natural frequency of the system of problem 2? So is there another way to show that denominator right there that has the zeta and omega n in it?
Yes.
What is that?
Look at the table.
We could show this s squared plus 6s plus 13. What is the other way? S squared plus
2 zeta omega n.
zeta omega n
Times
s plus
Omega n squared.
omega n squared. Now what are we being asked?
What is omega n?
Omega n equals
Root 13.
root 13.
It's very easy.
No, I need to change this problem. That 13's got to be 66.
What's zeta? That's
Paying
me.
attention. 6 is equal to what?
What it is.
So, can I solve for zeta?
Yes.
Yeah. Equals, let's see, 6 divided by 2 times the square root of 13.
I like how you bolded system in this problem.
Pardon?
I like how you bolded system in this problem.
Trust me, people miss it anyway. Plenty of people will miss it anyway.
I almost did, and I got confused when I first read it.
What's the next piece? C. Is there any questions about this? Actually, this is B and C, isn't it?
C and D.
C and D?
Yeah.
Part E is.
Oh, B was these.
Yeah.
So this is C, and this is D.
Yeah.
And E is what percent overshoot would have had if it had a step input.
Instead of this input.
Right.
How do I figure out the percent overshoot?
E to the negative.
Again, because A is a sign shifter, just do it this way. That's easier. And it always works, as long as A is, as long as the poles are left at plane. Otherwise, the percent overshoot doesn't make a lot of sense. What is it in this case? Which poles are we talking about, A and B?
So just
Yes,
to
that's
S.
input.
Not the
That
input,
X is-
because the input's different now.
So your A is your -3, your B is
Well, let me ask you this, the red ones or the green ones?
the red ones.
So you agree with Matt? Anybody agree with, do you disagree?
Yeah, it's the red ones.
Well, the most important agreement is mine. I agree with Matt. It's the red ones. It's the red ones. So right up here, red. What is A for the red ones?
-3.
So I'm gonna put 3 because of absolute value. B is
Yep.
2 pi. Anybody want to throw in that through the calculator to get the answer? Sorry, what was B? I can't read that. Okay, the 2. Yeah. Number 2, okay. All those different places.
0.9.
0.9, so 0.9%, less than a percent overshoot. Notice B is only a little bit smaller than A. It's what, 2/3 of A? And already we've gone down from 4% to about 1% overshoot. Significantly less. Anything else on this problem?
No,